transform of this function, we can use this linearity property. It is easy to find the Fourier sine and cosine transform of these two functions. And then by adding those Fourier cosine transform and by multiplying by the respective coefficient, we can obtain the Fourier cosine and sine transform of this function as well. So I'm not going to do that type of exercise. This is for your reference. If you have some problems, you can apply this application in when we are solving problems. So the next property that we are going to, oh no, not about the property. So now we are going to discuss the way of finding Fourier cosine and sine transform of derivatives. So here, don't think about these things. You don't need to worry about those things. This is the way of stating the theorem. Just remember this thing. So if you have to, we are going to consider a continuous function f of x, and it is, we are going to consider a continuous function of f of x, and then we are going to find the derivative of Fourier cosine and sine transform. So we have a function, so I'll write. So we are going to consider, we are going to obtain a derivative of f of x. So we have a function f of x. So if we take in the derivative of these functions, mean we are considering d over dx f of x. And we use the notation f dash x to represent this derivative of this derivative of the function. So now let's see, this function f of x, we can find the Fourier cosine and sine transform for this function. So let's see, this is Fourier transform. This f represent Fourier cosine transform of this function f, and f represent the Fourier sine transform of this function. So now we are going to obtain an expression for this new thing, the Fourier cosine transform of f dash x, the derivative of this function. And we are going to obtain an expression for the Fourier sine transform expression for this derivative f dash x. So to find this one, we can use these two formula. So the Fourier cosine transform of the derivative, we can obtain this as W times Fourier sine transform f of x minus square root of 2 over 5 f0. So here f0 means when x, the value of x is equals, when x is equal to 0, the value of f is representing this f of 0. And then the second one is the Fourier sine transform of f dash x, it is equals to minus w times the Fourier cosine transform of f of x. That means, so if we have to find Fourier cosine transform of the derivative of f, then we need to consider this first expression, w times Fourier sine transform. So let's see, I will spare this color. Here we are going to find the Fourier cosine transform, but the expression is included the Fourier sine transform of earlier function. So we can to find Fourier cosine transform of the derivative, we are going to consider W times Fourier cosine transform of the function f minus this thing. And to find the Fourier sine, the derivative of Fourier sine transform, we are going to consider minus W times Fourier cosine transform of the original function. So, first you need to find these two. When you are asking to find the Fourier cosine or sine transform of the derivative, first you need to find these two, the Fourier sine and cosine transform of the respective function f. Then you need to substitute those functions into this place to obtain the answer. So can you give it a try to find this one? So if we have to find, if we need to take the derivative of d over dx of f dash x. So what is the result that we can obtain? It is the second derivative of f. So if we ask to find the Fourier sine and Fourier cosine transform of this second derivative, what can we do? We have the way of finding the derivative. If we have some function, then we have the expression to find its the Fourier sine and cosine transform of its derivative. So here we are asking to find the second derivative. We already have the expression for the first derivative. We are obtaining the second derivative by differentiating first derivative again. So to obtain these two results, we can starting from this expression, but our function here we are considering is not fx, but it is f dash x. Can you try to obtain an expression by substituting f dash x instead of this fx in this right hand side of these two expressions? Okay, first we are going to obtain the expression for Fourier cosine transform of the second derivative of a function. So here, as I mentioned earlier, first we can write this is equals to by this the right hand side of this expression, we have to replace f by f dash. So we can write this is equals to w times Fourier sine transform of f dash x minus square root of 2 over 5. Is it f0 or f dash 0? Huh? f0 or f dash 0? It should be f dash 0 because we are replacing all the f terms in this expression by f dash. So this, what is the meaning of this one? This symbol f dash 0. It is the value of f dash x when a value of the x is equals to 0. So then here we have obtained this expression, and then uh, we can substitute this Fourier sine transform of f dash x. We already have an expression for Fourier sine transform of f dash x. So let's label this as star. So this part is equal to the left hand side of this equation star. No? So we can replace this Fourier sine transform of f dash x, this term, by minus w times Fourier cosine transform of f of x. Is it clear? මෙන්න මෙතන ගත්තහම දැන් අපි හොයන්න යන්නේ Fourier cosine transform එක second derivative එකට. එතකොට අපිට expression එක එනවා w වතාවක් Fourier sine transform of f dash x minus square root of 2 over 5 f dash 0 කියලා. මෙන්න මෙතන Fourier sine transform of f dash x කියන එකට expression එකක් අපිට කලින් තියෙනවා. නේ? So we can replace that term by that expression. මේ star කියලා අපි නම් කරලා තියෙන expression එකේ right hand side එකේ තියෙන්නේ left hand side එකේ තියෙන්නේ Fourier sine transform of f dash x. එතකොට මෙන්න මේ term එක මේකට සමාන වෙන හින්දා මෙතන තියෙන මේ Fourier sine transform එක f dash x කියන එක අපිට මේ term එක replace කරන්න පුළුවන්. Is it clear? Okay. Then we can write the Fourier cosine transform of f double dash x is equals to w වතාවක් minus w and this thing. It is equals to minus w to the power 2 Fourier cosine transform of f of x and මේකට මොකුත් වෙනසක් වෙන්නේ නැහැ. Minus square root of 2 over 5 f dash 0. So we can use this expression to find the Fourier cosine transform of the second derivative of a function. So using the similar way, try to obtain the expression for second derivative, the Fourier sine transform of second derivative as well. Fourier sine transform of f double dash x. So first you need to replace first you need to replace the f of this expression by f dash and then substitute this expression into this place. So with that you can obtain the answer. So try to obtain it by yourself. Stop talking. මොනවද ඔයාලා කතා කරන්නේ? ඔයාලට මම පන්ති අතරේ කතා කරන්න පර්මිෂන් එක දෙන්නේ මේකේ අයි මේක රින උනේ අයි මේක ධන උනේ ඒ වගේ දේවල් විතරයි හරි වෙන දේවල් කතා කරන්න බෑ. හදන්න. Where is that energy? Did everyone sign? Course වලට යන අයට මේ excuse දෙනවා තියෙන්නේ. So by replacing f in the statement above by f dash, we can write this is equals to minus w times Fourier cosine transform of f dash x. But we already have an expression for Fourier cosine transform of f dash x. So we can replace that by, we can replace this term by that expression. What is it? Tell me what is it? Expression for Fourier cosine transform of f dash x is equals to w times Fourier sine transform of f of x minus square root of 2 over 5 f of 0. So we need to multiply this. So we are replacing this Fourier cosine transform of f dash x by this one. So we need to multiply this entire expression by this minus w. So we can obtain an expression for Fourier sine transform of f double dash x is equals to minus w squared Fourier sine transform of f of x minus, no, it's plus square root of 2 over 5 w f of 0. Please raise your hand if you have obtained this by yourself. මේ කළු පාට බෑග්ග්‍රවුන්ඩ් එකේ ලියන එක පේනවද සුදු බෑග්ග්‍රවුන්ඩ් එකේ ලියනකට වඩා? නැත්නම් සුදු එකේ ලියන එකද හොඳට පේන්නේ? ඈ? කළු පාට එකේ? Okay, so let's do this example. So we are asking to find the Fourier cosine transform of f of x is equals to e to the power minus ax. සුදු පාටින් ලියුවොත් පේනවද? ඒක හොඳට පේනවද මේ පාටවල වලට වඩා? ද කියලා බලමුනේ. Huh? So we are going to do the example number 3. We are asking to find the Fourier cosine transform of e to the power minus ax. So to find this one, we can use the definition that we have learned in the previous session. But not, I am going to use the derivative expression rather using the definition. So let's see. If we differentiate this one here, our f of x is equals to e to the power minus ax. So then, if we differentiate this, what is the answer that we can obtain? What is the derivative of this function? minus a times e to the power minus ax. And then let's take the second derivative as well. This is equals to minus a times minus a e to the power minus ax. So this is equals to a to the power 2 times e to the power minus ax. And we can see that I will rewrite this f double dash x is equals to a to the power 2 times e to the power minus ax. And here we can see that this e to the power ax is our original function f of x. No? Yes, then another. So then we can write an expression for this one as f double dash x is equals to a to the power 2 times f of x. This is a special observation that we have obtained by using this given example. මේ හැම එකටම එන එකක් නෙමෙයි. Okay. So then I will rewrite by changing the side. This is equals to a square times f of x is equals to f double dash. මේක අපිට තේරුණාද හැමෝටම? So then we are going to take Fourier cosine transform of both sides. By taking Fourier cosine transform of both sides. The expression start. FCT කියන්නේ මේ Fourier cosine transform. EST, BST වගේ ගන්න නෙමෙයි. So let's see what happened when we are taking the Fourier cosine transform of both sides of this expression. Fourier cosine transform of f double dash. So here, what about this left hand side? Here a is a constant. Since a is a constant, a squared is also constant. And we know that the Fourier cosine transform is satisfy the linearity property. So we can bring this constant term out. So we can rewrite this as a squared times Fourier cosine transform of f of x. This is equals to Fourier cosine transform of f double dash x. Okay. So we can write a squared. Write it again. This is equals to. Now let's replace this Fourier cosine transform of the second derivative of this function by the observation that we have obtained earlier. What is it? Go back with your note and rewrite the expression for the Fourier cosine transform of the second derivative. It is equals to minus w squared Fourier cosine transform of f of x minus square root of 2 over 5 f dash 0. So I will write it f dash 0. Okay, so let's go back with our example. We have our f dash x is equals to, what is f dash x? It is minus a times e to the power minus ax. So when x is equal to 0, we can obtain f dash 0. So when x is equal to 0 means minus a times e to the power minus a times 0. Minus a times 0 කියන්නේ මොකක්ද? 0. e to the power 0 කියන්නේ කීයද? It's 1. So minus a times 1 is equals to minus a times 1. So it is minus a. So then we can replace this f dash 0 by minus a. Is it clear how we obtain this one? තේරුණ නැති කෙනෙක් ඉන්නවද අතවසන් බලන්න? Okay. Then we can write this is equals to minus w. No, let's write this complete expression. In the left hand side, we have a squared Fourier cosine transform of f of x. And the right hand side, we have minus w squared Fourier cosine transform of f of x. Minus and minus. Minus times minus, it is plus a times square root of 2 over 5. And then we can see that in the both left hand side and right hand side, we have an expression of Fourier cosine transform of f of x. So if we bring this thing into this side, we can write the expression we can obtain an expression by subjecting Fourier cosine transform of f of x, because we are asking to find the Fourier cosine transform of f of x in our example. So let's see. Now we are going to bring this term into this side. Then we will obtain a squared Fourier cosine transform of f of x. What happened? Is it still minus? So it will become plus w squared Fourier cosine transform of f of x. And what is the remaining thing in the right hand side? A times square root of 2 over 5. So here we can see that this Fourier cosine transform of f of x term is common. So we need to take the common factors out. So what is the remaining? If we bring this common factor out, what is the remaining thing? It is a squared plus w squared. And the left hand side a over a times 2 over square root 2 over 5. And then what we are asking to find is Fourier cosine transform of f of x. Fourier cosine transform of f of x. So we can rewrite f of x by, what is our f of x? E to the power minus ax. This is equals to a over a squared plus w squared. Now let's write this square root term first. This is equals to square root of 2 over 5 times a over a squared plus w squared. This is the answer. So if we have used the definition, that means the integration related operation, still we have obtained the same answer. So the next topic that we are going to discuss is Fourier transform. So we have learned the complex numbers in the first module, mathematics module. So we need to use the theories for this because we have discussed two transformation methods, Fourier cosine and sine transform. In these both transform techniques, we use only real numbers. So we can call that this Fourier cosine and sine transforms are real transforms. So now we are going to discuss about something complex. So when the functions, when we are dealing with the complex functions and these similar operation, we can obtain the expression for Fourier transform. So this is here we are considering complex Fourier integral. So we have obtained the Fourier sine and Fourier cosine transform starting from Fourier sine and cosine integral. Here we are obtaining it using Fourier cosine integral. So I'm not going to discuss those things. These are the two expression to find Fourier transform of f and Fourier inverse Fourier transform of that thing. So let's see Fourier transform of f. So if we have a function f and we are asking to find the Fourier transform of that respective function, as I mentioned earlier, Fourier transform is also a integral transformation method. So we are obtaining a completely new function of a new variable starting from a function of variable x by applying an operation related with integration. So here the new function that we are obtaining, we use the symbol to we use the notation to symbolize it as f hat w. The variable of this function is w, the function is f hat. So the operation, integration related operation is 1 over square root of 2 pi integral from minus infinity to infinity f of x e to the power minus iwx dx. So here this f of x is the function that we are initiating with. So that means we are going to find the Fourier transform of this function f of x, and we are starting from that position, and then we have to multiply that function by e to the power minus iwx. So here this I is the, what is the meaning of this I? It's the square root of minus 1. The notation for a complex number. And then here we need to use integration by parts to obtain the answer, because it is given as a product of two functions. And then by integrating that one and by multiplying the result of the integration by 1 over square root of 2 phi, we will obtain this f hat w. So by obtaining f hat w starting from this f, we call that process is the Fourier transform. And we call this f hat w is the Fourier transform of the function f of x. And then if we have f hat w, the Fourier transform of f, then we can find the original function f of x by considering this integration 1 over square root of 2 phi integral from minus infinity to infinity f hat w e to the power iwx dw. So by evaluating this integral and then by multiplying the answer by this 1 over square root of 2 phi, we can obtain this f of x. So we call this as this inverse, the process as inverse Fourier transform. And then this f of x, we can call this f of x as the inverse Fourier transform of f hat w. Okay, so another notation, and we use this f of f to represent this f hat w thing, as we have used in the Fourier cosine and sine transform, we use this C and S letters, but in the complex Fourier transform, we are not using those letters. We use only this letter F to represent Fourier transform, and we use this F inverse to represent inverse Fourier transform. So let's do this example. This is the easiest one. Complex number සමතකයි නම් ඉතින් කරන්න දෙයක් නැහැ. So the example number 4, I will write it here. We are asking to find the Fourier transform of f of x is equals to 1 if absolute value of f of x, absolute value of x is less than 1 and is f of x is equals to 0 otherwise. So it is given as f of x is equals to 1 when the absolute value of x is less than 1 and f of x is equals to 0 otherwise. So let's consider the entire x-axis. If we consider this entire x-axis, so let's first draw the graph of this function. So to draw the graph of this function, we need to consider x-axis and y-axis. So this is our x-axis, and let's see, this is our f of x-axis. And then it is given as f of x is equals to 1 throughout the region absolute value of x is less than 1. So can anyone know that the meaning of this symbol? Absolute value of x is less than 1. The absolute value of x less than 1 means the value of x varies in between -1 and +1. So if absolute value of x is equal to 1 means x is equals to +1 or -1. So it is less than 1 means it should be varies in between -1 to +1. So we can see that starting from -1 to 1, the function value is equals to 1. And it is f of x is equals to 0 for all the remaining cases. So this is the graph of the function. The function value f of x is equals to 1 when the value of x is, absolute value of x is less than 1. And it is 0 for other cases. So then we can obtain this as the graph of the function. So we are asking to find the Fourier transform of this function. So let's write the expression. Fourier transform of the function means f hat w is equals to 1 over square root of 2 pi integral from minus infinity to infinity f of x e to the power minus iwx dx. So here the variable of integration is x and the upper limit and lower limit are minus infinity and infinity. So if we consider minus infinity means the end of this x-axis from this side and plus infinity means the end of the x-axis in the positive side. So if we consider the starting from minus infinity to plus infinity means we need to consider the entire x-axis. And here we can see that we can divide this x-axis into 3 pieces. Starting from minus infinity to minus 1, minus 1 to 1. And what is the remaining piece? 1 to infinity. So we are dividing this entire x-axis into 3 pieces. So that means we can divide this integral also into 3 pieces. So let's only consider, rather than considering all the entire expression, we only let's consider this part first separately. So we are going to consider minus infinity to infinity f of x e to the power minus iwx dx. So we can see that we can divide this integral into 3 pieces, starting from minus infinity to minus 1, f of x e to the power minus iwx dx plus minus 1 to 1, f of x e to the power minus iwx dx plus from 1 to infinity f of x e to the power minus iwx dx. And then if we go back with the graph of the function, we can see that for the first piece, starting from minus infinity to minus 1, the value of fx, the function is equals to 0. And for the second piece, starting from minus 1 to 1, the function is 1. Again from 1 to infinity, it's again 0. So we can replace our f of x by those 3 values. So for this one, this is 0, this is 1, and this is again 0. The 0 times something is 0. So if we integrate 0 with respect to any variable, our result, the entire integration is equals to 0. Similarly, this one is also 0. So the only remaining part for this respective example is integral minus 1 to 1, 1 times e to the power iwx. It is equals to e to the power minus dx.
Recording stopped.
Okay, let's do this example. Let's complete this one. So we have to integrate e to the power iwx with respect to variable x. What is the integration of e to the power iwx? E to the power minus iwx over iw. Yeah, it's minus iw. Then we need to substitute minus 1 and 1 into x. So we will obtain the power minus iw. No. Let's bring this minus iw term out. 1 over minus 1 over iw times e to the power minus iw minus e to the power iw. So we can rewrite this as this equals to, we are going to multiply the term inside this bracket by minus 1. So we can obtain 1 over iw times e to the power iw minus e to the power minus iw. So then this is the result that we have obtained for this part of the integration part only. But to obtain the Fourier transform of w, we need to Fourier transform of the function f of s, we need to multiply this by 1 over square root of 2,5. So we can obtain the answer f hat w is equals to 1 over square root of 2,5 times 1 over iw e to the power iw minus e to the power minus iw. And here we have discussed an important formula which called as Euler's formula in the complex numbers. Can anyone remember the Euler's formula? Euler's formula is e to the power ix. This equals to cosine x plus I sin x. So here we have a function which consists of w terms. So we can write the Euler's formula for this e to the power iw. Okay, tell me. It's w plus I sin w. How about e to the power I minus iw? It should be cosine minus w plus I sin minus w. උගන්න මේවා මතක නැති එක වෙනයි උගන්නලා නැහැ කියන්න බෑ. So then cos w is equals to minus cos w. The minus cos minus w is equals to minus cos w. This is equals to cos w. We have discussed cos minus theta is equals to minus cos theta. And then how about this one? Sin minus w? It is minus sine w. So we will obtain this as minus sine w. So in our expression, we have e to the power iw minus e to the power minus iw. So that means we need to consider, let's label this as equation number 1 and equation number 2. E to the power iw minus e to the power minus iw means we need to consider 1 minus 2. So cosine w plus I sine w one minus, that is 2. Cos w minus I sine w. So we can write this as cos w plus I sine w minus cos w, minus and minus become plus I sine w. So here we can see that this cos w to this cos w cancel out. So the remaining part is what? This is equals to 2I sine w. So this is the expression that we have obtained for the bracket term. So we can write the final answer. The Fourier transform of the function f of x is equals to 1 over iw times square root of 2 times 2I sine w. And here we can see that this I to this I cancel out, and here there is 2 and in the denominator square root of 2. So we can write this 2. This 2, we can write this as square root of 2 to the power 2. So then this 1 to one of these term cancel out. So the answer that we have obtained as the final answer is f hat w, that means the Fourier transform of the function f of x is equals to square root of 2 over 5 times sine w over w. This is the answer. Let's do one more example. Okay, let's do this one as well. You are asking to find the Fourier transform of e to the power e to the power minus ax. Then x, it is f of x is equals to e to the power minus ax. Fourier transform of f. It should be Fourier transform of this thing, Fourier transform of f. F of x is this one and f of x is 0. Example number 5. Example number 5. It is given as we are asking to find the Fourier transform of the function f of x is equals to e to the power minus ax greater than 0. Is when x greater than 0. F of x is equals to 0. Is for x less than 0. Okay. Now here the question is correct. So we need to find the Fourier transform of f of x. Okay, let's recall the expression 1 over square root of 1 over square root of 2 phi integral from minus infinity to infinity f of x e to the power Nidhi the So here we can see that the function is defined as one way for x when x greater than 0 and another way for x less than 0. So we can divide this interval into integration, the limit of the integration into two pieces. So as earlier, let's only consider this part first. So we are going to consider integration from minus infinity to infinity f of x e to the power minus I w x dx. This is equals to from minus infinity to 0 f of x e to the power minus I w x dx plus 0 to infinity f of x e to the power minus I w x minus I w x dx. And we can see that in the problem it is defined, the problem is defined as f of x is equals to 0 when x less than 0 and it is equals to e to the power minus ax when x greater than 0. So we can rewrite this integral is equals to from 0 to infinity. We can replace this f of x by to the power minus ax e to the power minus iwx dx. And then since e term, exponential term, the both functions are is related to the exponential, we can rewrite this as by adding the exponent terms. So it is equals to e to the power minus a plus I w x dx. Now you need to integrate. So this is equals to e to the power minus a plus I w x over minus a plus I w, and we need to substitute lower and upper limit for the variable x. So if we substitute infinity, e to the power minus infinity, it is goes to 0. So first term is 0. And if we substitute x by 0, we will obtain the answer as, so I will substitute e to the power minus a plus I w times infinity over a plus I w minus e to the power minus a plus I w times 0 over minus a plus I w. And here, this part goes to 0. That means, since the numerator goes to 0, the entire term goes to 0. So we can say that this is equals to 0. And we can multiply this minus and this minus. It becomes plus 1. And minus half over a plus I 0. E to the power 0 can here. It's 1. So we will obtain the answer for the integration as 1 over a plus I w. So, but we are asking to find Fourier transform of the Fourier transform of e to the power minus ax. So we need to multiply this by square root of 2,5, because earlier case we only consider the integration part only. We need to multiply the result that we have obtained from the integration by 1 over square root of 2,5. So your answer should be a plus IW. Okay. So that is the end of that example. We have still 15 minutes. Then we give a 30. Okay, then the linearity property of Fourier transform. As I mentioned earlier in the Fourier cosine and sine transform, this Fourier transform also satisfies the linear property. That means if we have two function f of x and g of x and two constant, we can find the Fourier transform of AF plus BG by considering A times the Fourier transform of F plus B times the Fourier transform of G. So you can use this concept when you are solving some examples. Then the next thing, Fourier transform of derivatives. This is something important. So if we have some function f of x and we know the derivative of that function by using the we have a function of f of x and we know the Fourier transform of that function and we are asking to find the Fourier transform of the derivative of the given function. So then we can use this formula. So the formula is the Fourier transform for the derivative. I will write it. We have a function f of x and we know the Fourier transform of this f of x. And then the derivative of this function is f dash x and we are going to obtain an expression for the Fourier transform of this derivative of the function or the derivative of this function. So we can obtain an expression, the Fourier transform of f dash x. This is the Fourier transform of f of x. So by using this expression, we can obtain the expression for the Fourier transform of second derivative as well. So as we mentioned earlier, we are going to replace the f in this above expression by f dash here. F by f dash x. And then we can replace the right hand side of the statement star in the second statement. So we can obtain IW times IW, the Fourier transform of f of x. So IW times IW. What is it? I squared W squared, the Fourier transform of f of x. Here we know that I is the square root of -1. So I to the power 2 should be 1. So Okay, let's see this example. We have obtained
Recording in
we
progress.
have obtained we have obtained the expression for the derivative and the second derivative of a Fourier transform. And then now we are going to do the example number 6. We are going to find the Fourier transform of the function f of x is equals to x e to the power minus x squared by using
Recording stopped.